Are lines that intersect and form 90-degree angles. So right angle. And the slopes are negative reciprocals of each other. The symbol for perpendicular is an upside down T. So you don't actually have to write the word perpendicular anymore. You can just do the upside down T. I will know what you're talking about. Negative reciprocals. If one slope is 2, the other one would be negative 1/2. If one slope is 2/3, the other slope would be negative 3/2. So these are the slopes. So perpendicular slopes are flipped and negated.
Is that y equals mx plus b? Is that that?
Yeah.
Really?
Okay, a perpendicular bisector is a line, a segment, a ray, or a plane that is perpendicular to a segment. It has to be a segment because you can't bisect a line or a plane or a ray because you can't cut those in half because they don't have length, because they're infinite. So it has to be a segment. So it's perpendicular to a segment and it bisects it. So it's perpendicular and cuts in half. Okay, so anything that's perpendicular to a segment and cuts it in half is a perpendicular bisegment. Bisector. Except for obviously a point, because that's a midpoint. Points don't bisect, they just hang out. Okay, then we have some theorems. Through a given point on a line, there's exactly one line in the plane perpendicular to the given line. So that tells me if I have some line and I have a point on it, there is only one line that exists that would be perpendicular through that point, right? I can't draw some line over here, it won't be perpendicular. There's only going to be one line that would be perpendicular. Okay. If two lines are perpendicular, they form congruent adjacent angles. Well, if you think about perpendicular, that's 90 degrees, right? Well, so's that, so's that, so's that. So actually it's 4 congruent angles. So the angles next to each other are all adjacent congruent angles. So the opposite of that, so if you've got perpendicular lines, they're forming congruent adjacent angles. So the opposite of that is if you have congruent adjacent angles, that means it has to be perpendicular. And if you think about that, that makes sense, right? Because if I have adjacent angles on a line, they're supplemental. If they're congruent, it's 180 divided by 2. Like if these two are the same, it has to be 90. There's no other way for it to be. And then only one perpendicular can be drawn from a point to a line. So here we had a point on the line, only has one perpendicular. Here if we have a line and we have some random point, there's only one line that can go through that point that would be perpendicular to this line. I can't draw any other line and it still be perpendicular to that line. So they kind of, in a linear pair are congruent, then they have to be right angles. And we talked about that, right? Because we talked about if this is 180 degrees, all of this, right, is 180. And if these two are the same, they have to both be 90. So they're both right angles. So we have AC is the line, and we have a ray DB, or BD. But actually it's ray DB because D is the vertex. So if we have the segment, if we call AC a segment, and we take off the ends and we just talk about from here to here, and we talk about DB as a segment, just as segments, they are perpendicular to each other. So that's how you would write AC is perpendicular to DB as segments. But we could also talk about them as a line and a ray, and I could talk about the line AC being perpendicular to the ray DB, and it has to be DB because D is the vertex. So this would be the line and this would be the ray. So you can talk about the segments, or you can talk like the pieces, like we cut them out, or you can talk about the whole thing. Now, if I say this part AD is congruent to DC, again, I'm talking about segments. So if these two pieces are the same length, then that makes DB the perpendicular bisector of AC. So if I'm, again, it has to be segments at that point because I can't bisect a line because lines are infinite, so you can't cut infinity in half. But I can say that if I just talk about the segment, DB would be the perpendicular bisector if these two pieces are the same length. So we're going to find the measure of angle X. What I have is, actually I should do that. This is a straight line, correct? So that makes this entire thing 180. And if this is 90, that makes this part 90. So if I have X and 37, those are going to add up to 90. So if I do 90 minus 37, I'll have X. So 90 minus 30 is 60, minus 7 is 53.
Oh. That's how I do it too.
Is that how, it's easier that way, isn't
I
it?
did it backwards. I did 180 minus 90, and then I get
Yeah, it would be the same thing, right? 180 minus 90. Yeah. Okay, another example, we have all of this, right? I have a bunch of perpendiculars going on according to this. So I'm going to mark what they've told me. So JN is perpendicular to OL. So this is JN, that's OL, so they're perpendicular. And then OK is perpendicular to OM, so that would be perpendicular this way. So I have two perpendiculars. Now, I don't actually need that for this particular problem, but so I have these two. They form a perpendicular angle, which means they add up to what?
180.
No, just the perpendicular.
Oh, 90.
90. So 5x minus 13 and 3x plus 7 will add up to 90. So far, good?
No, where'd the red square come from?
That's this part.
Okay.
I was just labeling. They gave me information, so I labeled it just to have it. Yeah.
All right.
So I'm going to add 5x and 3x to get 8x. Negative 13 plus 7 is negative 6. I add 6 to both sides, so I get 8x equals 96. Divide both sides by 8, so x is 12. Okay. Now we could take this further if the question asked us to and find the measures of these angles by plugging 12 in for x, right? So if I did this, it would be 3 times 12, which is 36, plus 7, which is 43, right? 43. 5 times 12 is 60, minus 13 is 47. 43 and 47 make 90, so we're good. Now, if these two make 90, if this one's 47, what's that make this one? 43. And if this makes 90, if this is 43, this one has to be 47. So we could find all of the angles if we had to. Yeah, just by finding the first two because of the two perpendiculars.
That's why you drew the right angle.
Yeah. All right, so we've got this proof, right? Angle 1 is congruent to angle 2. Well, that's my given statement. So that's given. They form a linear pair. I've got that from the picture. They're making a line, right? They make a straight line, so they're a linear pair. They're right angles because congruent linear pair are right angles. And if they are right angles, that means that line M is congruent, or perpendicular, I mean, to line N. Like line M is perpendicular to line N because that's the definition of perpendicular, is that it's right angles. Okay. Any questions on that particular one?
So that we do with perpendicular to the design.
Yeah, perpendicular, right angle, 90 degrees, they're all the same thing.